Here's a tutorial for the Physics Classroom Stoichiometry Concept Builder. Watch the arrows, the hand, I guess. So here's a balanced reaction. In our little table here, the given data is in purple, and I made up most of these so that I'm not doing it for you. Let's remember what a balanced reaction means. 4 of these and 6 of these will make 5 of those and 6 of that. But it's just proportions. If you want to use 40, you just need to realize that you need 60, which will get you 50 and 60. So if you put in 4, you will need 6, and you'll get 5 and 6. So that's the total easy one. Let's change to this is the given. I want to make 2. That's fine, you can do that. But that is 1/3 of the 6 ratio number here that we were using. So if you're going to make 1/3 of this, you'll get 1/3 of the 5. You'll get 1.67. If you want to make 1/3 as much, you need to use 1/3 as much, and 1/3 of 6 is 2, and 1/3 of 4 is 1.33. Here's our given data. Now, instead of using 4, you're going to use 8. That's fine. You doubled the recipe here, so you need to double the recipe here. Double of 6 is 12, which will get you double of 5 and double of 6. You can also use something that's not an integer multiplier. So this is not double, it's not triple. You're going to use 6, that's fine. Take 6 divided by 4. That's a multiplier of 1.5. If you're going to use 1.5 of this, you need 1.5 of those. So you'll need 8 of this, and you'll get 1.5 of 5, which is 7.5, and you'll get 1.5 of 6, which is 8. This next set of examples is covering portions 2 and 3 of the concept builder. So here we have a balanced reaction. And this means if you have 3 of these and 2 of those, you get 1 of those. But we're going to talk about moles and grams versus moles and grams. And this gets a little bit more complicated. You really might need to stop and think and rewind something. Let's start off easy. If you have 2 moles of this, of N2, how many grams is that? Well, the molar mass is 28, so 228 is 56. If you have 1 mole of this, well, what's the molar mass of that? You can just look it up. It's 199.6 grams for every 1 mole. How many moles are you using? 1 mole. Well, then you would have 199.6 grams of it. Our second and third runs are where it gets more complicated. Purple is our given information. I'm going to use 140 grams of the N2. That's fine. You can do that. How many moles would that be? Well, when you divide by 28, the molar mass, you find out you are using 5 moles of it. Now, what this says is 2 of these will get you 1 of those. In other words, you will make half as many of these as you have of that. If you want to put in 20, that's fine, but you'll only get out 10. If you want to put in 50 of these, you'll get out 25 of those. It's just a ratio of 2 to 1. It's like baking cakes. You can just scale it up and down. You can make 50 cakes at a time if you want, but you need to scale everything up by 50 then. So we're going to scale this up so that we're using 5 moles of this. So how many of these will you get? Well, the ratio says you'll get half as many, right? You will get 1 for every 2. We'll get 1 for every 2 you put in. You'll get half as much. So we're going to take the 5 and multiply by a half. That's where we got the 1, invisible 1, over the 2, and we will make 2.5 moles of that. Because we put in 5, we only get out half as much. We will get out 2.5 moles. Times the molar mass means we would produce this many grams of the product. Let me emphasize that this does not mean if you put in 3 grams and 2 grams, you'll get 1 gram. It doesn't even make any sense. If you put in 3 grams of something and combine it with 2 grams of something else, unless you did a very poor job and you spilled a bunch of it down the drain or something, you had better get 5 grams. 3 grams plus 2 grams is 5 grams, and I don't care what it is. So it would be impossible to say 3 grams and 2 grams combines to make 1 gram. It's banana pants. However, if you do it in items, it can make sense. 3 red Legos plus 2 red Legos can make a set of Legos that has all of them in there, but it's only one set. That can make sense. If you take 4 tires and 1 car body, you can make 1 car. So items do match this way. Let's go to line 3. Here's my given information. I want to make this amount of grams. Okay, divide by the molar mass. Turns out you made 7 moles of it. If you make one of these, how many of those do you need? 2. If you want to make 30 of these, how many moles of those 30 moles, how many moles of this do you need? Double it, 60. We're going to take the moles here. We're going to multiply by 2 over 1, 2 over 1, and realize we need to make 14 moles of the N2. How many grams would that be? Multiply by the molar mass, and you would need to measure out 392 grams. Why do we care about that? Why can't I just stop at moles? Because nobody has a mole scale. It's impossible. And every year I have to say this because, no one's thought of it until they get to chem class. But you can't have a dozens scale, can you? You can't design a scale that gives you a dozen eggs. You have to divide out of the grams or pounds that the scale can sense, and you discover how many dozen eggs it is. But it can't just read dozens because it just has no idea. That's not possible. So when we know how many moles you need, then we have to look for how many grams we need to put on the scale. And that's what we would need to start with so that we end up with that.